Right, so continuing to talk about how life becomes preserved, we've said that if the organism has hard parts like teeth, bones, shell, it's more likely to be preserved, but we do still get fossils of soft body parts like very thin insect wings or tiny little spider legs, right? So how are we able to, or how are these soft parts able to be preserved? Well, they're less likely to be preserved, but in some situations they still can be. One example of a way to perfectly preserve these soft parts is with amber. Amber is just the hardened resin of conifers and other some broadleaf trees, I think like sap. And if an insect or a bird or something else like that becomes trapped in the sap when it's still sticky and wet, and then that sap turns into the hard resin, that amber, then the organism, like the spider, can be preserved for a very long period of time. Now, just like this sticky sap, this sticky resin, oil and mud can do the same thing. So the La Brea tar pits out in California, maybe you've heard of those, they were ancient pits that were really muddy, but also had a lot of oil and tar in them naturally. And so when organisms fell into them, it was sticky, they couldn't get back out. They sank into the tar pit and they became very well preserved. So this is, the La Brea tar pits are an area where we find so much evidence. We have evidence of saber-toothed cats and other mammals, but we've also got things that are less likely to be preserved, like birds and insects and plants, all preserved in this goop, right? This hardened goop. So this is one of the places that we're able to find evidence of skin and hair, things that wouldn't normally be preserved if they weren't preserved within these tar pits. But as we've talked about, sometimes only traces remain. And even though we don't have any material from the original organism, we don't have hair, we don't have skin, we don't have bones, we just have the traces, these can actually be very helpful into understanding that organism's behavior. Okay? So if you think about it, if you look at these dinosaur footprints, well, we can figure out how they moved, right? We can figure out, did they walk on 2 legs? Did they walk on 4 legs? Were they bipedal, quadrupedal? How many toes did they have? And does that mean they walked on their toes like a cat, or did they walk flat-footed like a human? Okay. Did it have a really long body, a really short body? Was it lightly built or really heavily built? Did it have webbed toes? That might tell if it was aquatic or not. Did it have claws? That would tell us that it would be a predator probably, right? So just based on those traces, we can understand a lot about an animal's body makeup, how it behaved, its place in the ecosystem. So I want you to keep that in mind, looking at this image, and try to figure out what behavior do we see in this trace fossil. First, you have to find the trace fossil, and then think about what behavior are we seeing here. Okay. So this fossil, what you're actually seeing is a trilobite that's preserved over there on the bottom left, and the trilobite path behind it, right? The path made by the trilobite's tiny little legs and feet as it crawled across the seafloor. So here we are seeing trilobites crawling, and we're able to figure out, well, how did trilobites move? Did they move in straight lines? Did they meander? Did they go after food? Right? What were they doing? What was their behavior? All right, one more time. What behavior do you think you see here? This is a trickier one. This fossil, it's another trace fossil, and what you're seeing is the sweeping motions of a feeding worm. Okay? So as this worm swept back and forth, eating whatever was in the sediment, it left these paths behind. So we can figure out this ancient worm, how it ate, right? How it moved around to get food. So trace fossils are actually very, very powerful in terms of preserving evidence of past life.